Hey guys, it's Cugsley, and welcome back to another video. So I'm just making this because I have yet again successfully optimized this input mapper chip, and I just wanted to show it off real quickly. So I'm not going to go super into depth on how it works since I've made previous videos kind of explaining the general functions. This timeline here is the only thing that I don't think I really explained too much of, but basically it's just like a setter that dictates what you're selecting when and kind of how to set the values, but doesn't dictate what to set the values to. So you can ignore that for now. I recently updated my value assignment chip, and I was able to optimize it and shave off a whole 1.5% from everything here. Allow me to show you how I did that. Let's actually just go into a previous version all the way back from August. So originally, again, we'll close this stuff here, doesn't matter. Originally, how the value assignment works is you had two things. You had your actual menu, which handled how you interact with the logic and how you set stuff up, so your keystrokes, all that stuff. This is blank right here because I programmed it to work directly with the player logic. So without the player in here, the chip is kind of useless, but that's just so I could have optimized it more. But this is how you're supposed to interact with the menu and actually set values, right? And then what this chip here does, value assignment, is it's able to save the values that you assign to each button, and it is able to create a list of buttons that you selected, so that way you can like manage them. So what it looks like is this: like when you're in the menu here, right? If I say do default, it shows this here. And what this list of buttons is, showing what each function is correlated to, is dictated by this GUI, or graphical user interface. So what happens is you have a little setter here, I guess, a timeline that really quickly goes through all of it, right? Let's do it again. And it just really quickly sets this, sets this, sets this, sets this. It just goes down the list, setting all of them. Now, originally, the way that it worked was it would do a few things. It would take a variable. So the way it works, I'll go into how this works in a bit of detail. So you have 3 components per item that it checks. So you have like interact, jump, throw item, drop item, stuff like that. There's 3 things here. The first one is the variable modifier for the actual variable, and it just gets the value. So it says, hey, the interact variable, what value is that? It retrieves it, and it sends it off in this wire, right? And it goes into here, but we'll get to that. This button here temporarily turns off. Let me actually go in here. This button, or this keyframe here, temporarily turns off this microchip. So if there was a value stored in this signal manipulator, it's reset when it's turned off. So this is just kind of like a quick refresh before it sets the value properly. And this is kind of like a signal buffer, and I'll explain how that works. So once it gets its value, right, let's say it's checking interact. Hey, I have a value for interact, so follow the wire. It goes into this microchip here. And this is our decoder. So it takes the value that it gets from the variable that's active. So again, it goes 1 by 1 by 1 by 1. So to make it a bit easier to look at, it would be kind of like this. Let me hide some of these fucking wires, huh? So to make it easier to kind of visualize, right, in that it's individual, let me like separate them. Separating them like this actually breaks the program, but you get the general idea, right? So here's how it looks. And some of them aren't 100% lined up properly just because of some inconsistencies in how Dreams works with fast timelines. But now you can see it's 3, 3, they're in columns, right? So let's say that it's checking the first item, which is going to be interact, right? It takes the value and decodes it because it's a 7-digit variable, right? It decodes all the digits to measure them to kind of see what button is interact, right? There's a whole decoding system for how I determine what button is what, and I store all that information in a single variable. Just know that this is what decodes it to get that information in detail. And then it recombines the raw values into just one big array and sends it off, right? So what happens is, when you decode it, it actually comes out as decimals. So it comes out as I think it's a double would be the variable name, like in actual programming, but it comes out as like 1.2 or 1.0, 1.2, 1.26, stuff like that, right? It's all over the place. So what happens is it goes back through this timeline. So it gets the variable, it sends it back through in the same kind of tick, right? And it rounds down all the values in the array to just the whole numbers. Now, the reason why I do it this way, right, is this. I want it so that way when it's checking interact, it only feeds the value, right, that it's checking into the corresponding interact, like kind of GUI setter, right? And the reason I do it like this is because let's say that I rounded it, right? Let's just say I rounded everything right here. And just delete all these wires. And then I just routed it. So let's say we got rid of these, right? And then let's just say I just routed this directly into the GUIs, right? Because, the refresh still turns it off and all that stuff, so it should be good, right? Not quite. And here's why. What ends up happening if you do that is because it only turns off for snippet and these GUIs are always on at all other points in time, if you route it this way to where there's just a singular round down and then it goes directly into without being fed back through this timeline here as kind of like a buffer or regulator, it'll update all these buttons simultaneously. In fact, what it looks like, I will show you. I'll only show you with one button, right? Because I don't feel like wiring all these back up. What you end up seeing is this. So all of these are turned on now, right? Because it was reading it as it's going down and constantly updating over top of itself. So what we do, in the old method at least, and I kind of keep it similar in the new one, what we end up doing therefore is we run the round downs through this to limit when it sends the value or when it sends the signal to each graphical user interface. And that's how we keep things consistent, okay? So that's how it works. And then once it goes in here, it saves the variable by looping into itself, creating kind of like a temporary save. And then it splits it up into different values and sends it to where it needs to go, right? Here's what I did to optimize it. Let me go to the newest one, kept everything almost the same, but I changed how a few fundamental aspects work. I actually ended up rounding everything before sending it through, but that is because I just replaced the round downs in here with cosine modifiers, like cosine functions. And the reason I did that, I have to explain. So the way that the GUI originally worked was it would check for a value of 1. If after decoding the variable, any one of these digits here is 1, then it displays, say, X. If it's 3, it displays the down button, like the down directional pad. If it's 4, it displays both, right? This dictates, do you have X as jump? Do you have the down button as jump? Do you have both X and down button as jump? I mean, you can make it multiple things. Well, I found out that, well, I didn't find out, I noticed very early on that it's not very efficient checking individually. Does this equal 1? No? Does this equal 3? No? Does this equal both? Yes? Okay, activate both. Does this equal 1? Yes, activate 1. Does this equal 1? No. Does this equal 3? Yes, activate 3. Checking all of these individually is really tedious. So we need to find a way to simplify that. As it happens, and let me demonstrate how I kind of came across this. I already known that you can put numbers into functions and get a unique kind of pattern of values to emerge. And I was playing around trying to see if I could find a useful kind of set. And let me show you what I got. Okay? Let's say I have a little thing here, and let's just set it to 1. And let's set this to 3. Okay? Now there are technically there are 5 different values I need to check for. 0, which means all off. 1, which means 1 is active. 2, which means nothing is active. 3, which means 3 is active. And 4, which means both of them are active. Right? Skipping all the experimentation, what you end up with is if you pass a whole number through cosine and then pass that through cosine, and then you get a decimal, and you're able to kind of put that into a progress bar on a timeline, right? So what you end up seeing is this: 0 is somewhere in here. 1 is let me actually get rid of the decimals there. 1 is up here. So therefore, we will put 1 right there. 2 is right there. Doesn't have anything. Good. Because again, 2 is a value that doesn't exist. 3 is right here. That's good. 4, let's put that right there. So now what we have is, and then 0 is empty. So what we have now, let me really fine tune it. It's a little finicky. What we have now is 0 shows nothing, 1 shows 1 is active, 2 shows nothing, 3 shows 3 is active, and 4 shows both is active. So I can run a whole number through these 2 functions here and get a decimal point that is able to differentiate between the values still, right? In such a way that when putting it into a progress bar, I can correspond it between 2 items, right? As opposed to, say, doing this, where it's like, like this right here, right? Because if I just did 1, 2, 3, 4, and 0, I can do that as well. I mean, that's a thing I can do. It's just not very efficient because now there's a whole extra item here, right? As opposed to 2 text boxes, now there's 3. 0 is good. Oh. Yeah, I guess I should probably divide that by 4 to get a decimal point. See, I end up not even saving anything. Divide by 4. There we go. Okay. See, like 1, 2, 3. Oh, did I mess this up? There we go. 4, right? So you can do that, but it's just not as efficient because now you're using multiple text boxes. You're using 3 instead of 2, and you're still dividing anyways to convert that whole number into a decimal point that you can then add as a progress or a percentage. So not very fun. So what I did was I ran it through a cosine, ran it through another cosine, and then I was able to kind of dictate where that lands in these and kind of squeeze the most out of only 2 text boxes, right? Now, because I did a cosine and a cosine, right, I went from just this to a cosine, a signal saver, and then another cosine. So I just put that other cosine in here and replaced the round down calculators with these cosines, put the round down over here, and just kind of shifted everything over to the left a little bit. That way, I'm not individually rounding when I can simply offload the task of being individually processed to something else and consolidate the rounding. Otherwise, I would have 2 cosines over here and a bunch of round down calculators. Instead, if I'm already going to have 2 cosines per GUI microchip, I might as well put one of those cosines in here and have them just function separately and then consolidate the rounding down into a single wire. So that is how I was able to save a pretty decent amount of space and processing. What the actual savings looks like, and I'm really mincing here, but I still find it pretty cool, is this. Originally, the measurement for wires and animations was at 2.67 and things was at 2.5. Now, going forward, wires and animations is at 1.89 and things is at 2.5. So things is the same, but wires and animations has gone down because I've simply decreased the amount of wires that I'm using. I've kind of consolidated everything into one spot. I'm using more items now for like the timelines, which count as, an item, right? The added cosine. But then I'm making up for it by having consolidated this to begin with and just getting rid of extra fluff. Now, what this does is originally my system, before I optimized it, wasn't able to display multiple buttons assigned to a function simultaneously, right? A long time ago it was, but I had gotten rid of that to optimize it. I've since been able to restore that now. So let's go somewhere where it's very obvious. Let's actually go to checkpoint. So, like for example, yep, we'll go in here and we'll update this. There we go. So now, when you open up the menu, and let's put the menu against something bright like this here, I can now assign multiple buttons to the same thing. And granted, it looks like a complete mess, but you can see that there are multiple buttons on there now. Now it doesn't gaslight you into thinking there's only one button assigned. And you can still reset it if you need to. You can individually delete one item and do it back on. That's all the same, right? You can do like up and down and left and right. Like you can do a bunch of different ones on here. So there we go. Pretty cool, huh? Now, it looks like there may still be some glitches with the assignments of buttons, specifically with the arrow keys, which is rather interesting. So I'll have to take a look into that and make sure I fix it up and smooth things out. Since I'm working with timelines that are extremely finicky, it could be they aren't just quite fully processing it how they should. But that's a pretty simple fix. It just comes down to making sure all the arrows are as they should be. I believe it might only be with a few individual ones. Like if I were to reset everything here, I already know that this one's having issues. That one's good, 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 good. Then I go up. X is good with left. All of them are good with left. So you just kind of practice, or not practice, but you just kind of test them all out and make sure, like, the up button didn't work with that one. Up button did. Okay. Oh, whoops. Just set it back to that again. There we go. So yeah, just testing it out. I'm now noticing that specifically right and up are not functioning with the interact option. So yeah, there we go. And now I know that I need to get those two fixed. But in general, the optimization is all there. So that is how I was able to obsessively optimize that system even more. Saved a little bit of a percentage, and now everything is cool. Well, that's it. I just wanted to show that off real quickly. I'm still working on some cool stuff, but I won't go into too much detail. Here's a cool little snippet, though. You guys have a good night. Bye.